Good morning, everybody. Thanks for joining us to the webinar Freight Road Transport Costs with At Risk. My name is Alfredo Armijos. I am a risk consultant of Palisade Corporation, and during my presentation, I will introduce you in some of the different tools and techniques applied on transport cost modeling, combining Monte Carlo simulation, as well as other sensitivity tools with At Risk. Okay, let's start by looking at the agenda. Basically, I have divided my presentation into three parts. In the first part, I will talk about the products and services that Palisade Corporation offer to our customers in risk management and decision-making topics. Then, in the second part, I will look at the analysis of risk and uncertainty of cost centers in the trucking industry, applying Monte Carlo simulation as well as other advanced sensitivity tools with At Risk. Finally, I will answer some of the questions that you will have throughout the presentation. Now, I will look at to move on the next part that is about our company, Palisade Corporation. Palisade Corporation was founded in 1984 in Ithaca, New York. Our headquarters are located there. We have also several offices in the world, basically located in London, Tokyo, Sydney, Sao Paulo, and Cuenca, upon which we provide consultancy services, training, and technical support to our users across the globe. We are market leader in quantitative risk analysis and decision support software and services. Over 200,000 customers are using our software currently worldwide. Most of them are part of the Fortune 500. And finally, our products are taught at the top 50 MBA programs in the United States of America, as well as in other universities in the world. Now, I will explain you about our different products and services. Basically, the most important that is Palisade Decision Tools Suite. Palisade Decision Tools Suite is a powerful platform of different optimization and risk analysis tools and techniques. The first one, that is called At Risk, is an add-in for risk analysis and optimization under uncertainty using Monte Carlo simulation. The second one, Precision Tree, that is an add-in for visual multi-stage decision analysis in Microsoft Excel using decision trees. Then Top Rank, that is an add-in for automated what-if sensitivity analysis on Microsoft Excel spreadsheets. Then Big Picture, that is an add-in for creating dynamic mind maps from any type of spreadsheet data. Neural Tools, that is an add-in for predictions using intelligent and sophisticated neural networks. Stat Tools, that is an add-in for regression, time series forecasting, and statistical analysis combined with Microsoft Excel. And finally, if you want to construct some of optimization models based on algorithms, genetic algorithms, heuristics, and method heuristics, you can use Evolver solution. Palisade Corporation also provides customized software solutions for risk and decisions analysis. For example, if you want to perform a probabilistic analysis on your calendars and on your budgets in project, we can use At Risk for project and combine with the different tools and techniques of Monte Carlo simulation and sensitivity analysis with At Risk. We can also combine Evolver and Risk Optimizer in order to perform better optimization models. Precision Tree for the construction of decision trees. Top Rank if you have a deterministic model upon which you want to add uncertainty in the key inputs of these models. Status if you want to perform descriptive and inferential analysis on your data. Neural Tools, Big Picture, if you want to perform your own models, if you want to customize your models on web page on and in your systems, you can use a Palisade custom runtime. We have also different training opportunities and consultancy services. For example, we offer public seminars in person or web-based. We have provide on-site training and consulting. If you want to model or perform or construct better models or increase the performance of your models, we offer model building and validation of them. We also have several books that could be useful in order to know more about our different products and services and apply most of them in your different issues about your industry. Now, I will talk about of different tools and techniques that you can use in transport cost modeling with at risk. As we should know, the key objectives of the logistics and transportation industry are essentially to maximize the level of service provided to customers as well as minimize simultaneously their logistics costs as part of its operations. Bearing in mind these goals, most of the companies such as logistics operators or businesses with their own vehicle fleets administration day-to-day face the challenges of reducing fixed and variable costs associated with their goods distribution operations or reverse logistics efforts. According to the American Transportation Research Institute in 2015, the cost centers in road transportation are basically divided by vehicle-based costs and driver-based costs, being the fuel costs and driver wages the most significant costs from a deterministic perspective, as we could see in the following graph. It's important to understand that all of these costs are the basis of the construction of annual transport budgets that usually are unrealistic due to the risk and uncertainty derived by the operations of this sort of companies. Hence, risks such as theft, fraud, corruption, natural catastrophes, market volatility, macroeconomic developments, and cyber incidents, as we could see in this chart, are examples of some of the challenges that companies of the logistics and transportation industry should face in order to be competitive in a VUCA environment, which is the acronym of volatility, uncertainty, complexity, and ambiguity. Naturally, all of these factors are part of the issues to be controlled, and that's why powerful tools such as at-risk could help us to do it. Now, I will show you a model developed in Microsoft Excel about freight road transport cost modeling with at-risk. So let me finish this presentation and then move on to the spreadsheet of the model. As we could see, there is a breakdown of average marginal cost per mile of trucking according to the American Transportation Research Institute in 2015. As you could see, there are all the cost centers regarding with motor carrier costs, such as vehicle base and driver base. In vehicle base, you could see fuel cost, truck and trailer leasing, repair and maintenance, truck insurance premium, permits and licenses, tires, and tolls. As well as in driver base, you could see driver wages, driver benefits. All of these costs per mile of trucking are divided from 2008 and 2015. As we could see, the total of all of these costs are basically the average marginal cost per mile of trucking per annum from 2008 to 2015. The big issue in these sort of models are essentially that we are not considering all of these risks that are affecting the right calculation of the final total cost of distribution of these sort of companies. And that's why tools such as at-risk could help us to do it. And the first part of this analysis is to identify which are the key input variables that could affect the total cost of distribution of a trucking company. So first of all, the key inputs, as we could see in this example, are basically all the cost centers of vehicles, as well as all the cost centers of regarding with the driver. So in order to introduce uncertainty inside of these cost centers, we could use probability distributions. At-risk provide us several examples of probability distributions, as we could see when we click on this button, define distributions. As we could see, we can classify all of these distributions into discrete distributions and continuous distributions. If we remember that time and cost are part of continuous variables, we should focus on the probability distributions regarding with a continuous variable. As we could see in this example, basically we have identified this probability distribution considering different parameters such as the mean, the standard deviation, or maybe the minimum value, the mode, and the maximum value of the average marginal cost per each one of the cost centers. For instance, if we could see, in order to model the uncertainty of a fuel cost, we could use a triangle distribution, upon which we will use the minimum value, the most probable value, and the maximum value. That is a little bit different when we analyze the uncertainty derived by the truck and trailer leasing cost, upon which we will use a normal distribution with the mean of the difference of average marginal cost, as well as the standard deviation of the average marginal cost from 2008 to 2015. So if we consider the uncertainty, bearing in mind all of these distributions, that all of them are basically applied into this part of the model. For example, if we consider the fuel cost, we could see that there is a probability distribution risk triangle that we obviously can construct it right now. If we just put equal risk triangle, that is the function in at-risk, in order to generate a probability distribution based on a triangular function, we just need to put the minimum value, the most probable value, and the maximum value. And here we are, we have our distribution. If we would like to see the graph about this probability distribution, we just click on and define distributions. So if we wait a little bit, we could see that now there is a clear uncertainty that is affecting naturally the fuel cost of the trucking services for these sort of companies, right? So for example, we could analyze the probability for exceeding a specific value. For instance, if we would like to know what is the probability of exceeding the cost fuel of $0.5 per mile, we could see that this probability is basically, we move the other slider, basically 33.1%. Or if you want to obtain the probability that the fuel cost is among, I don't know, $0.45 and $0.60, we could realize that this probability is 85.1%. As you could see, there are other statistics so useful in order to improve our analysis, such as descriptive statistics, minimum value, maximum value, mean, mode, median, and so on, and all of the percentiles that we could obtain according to this distribution. Now, if we apply the same logic to all of these cost centers, as we could see now in this column, right? We, for example, could check the distribution applied for, I don't know, repair and maintenance. Now, we could see that there is a paired distribution that will receive a minimum value and the most likely value, and the maximum value. All of these parameters were obtained at the first part of the model. And finally, we will realize that the total of all of these cost centers are basically the total cost per mile per truck, right? So if we want to apply Monte Carlo simulation, we should bear in mind three important aspects in order to apply this powerful technique. First of all, as we mentioned at the beginning of the presentation, it's important to identify the input variables. In this model, the input variables are basically fuel costs, truck and trailer leasing, repair and maintenance, truck insurance premium, permits and licenses costs, tires and tolls costs, driver wages, and driver benefits. The sum, or the total, of all of these costs are basically this variable. Then we should identify our output variable, which means that this is the most important variable that will help us to take decisions about that if that total cost per mile is correct or not, in order to fix different fees for establish the price of our trucking services, for example. So if we want to specify that, for example, total cost per mile is our output variable, we just simply need to click on in this button, add output, and then we can obviously change the name. For this example, I will apply the same name, total cost per mile, and then click on OK. And basically, the color of this cell is now in red color. The most important feature of when we use @risk is that @risk could help us to identify which are the key input variables colored by a blue color, right? And what are the output variables, and in this case are in red colors. Finally, if we want to apply Monte Carlo simulation, we just have to establish which quantity of iterations we will apply during our simulation. This is very important because one of the key advantages that @risk provide us is that you can apply the number of iterations that you want to perform. For example, if you want to apply 100 of iterations, 500 iterations, 1000 iterations, and so on. Or if I want to let that @risk could help me to identify which is the correct number of iterations in order to have a convergence of the total cost per mile, bearing in mind all the uncertainty added into the key input variables, we can just click on the auto option. That's the option that I will apply. So at the end, if we click on this button, random on static standard recalc, we should be reminded that if we, in some examples, like this, we can realize now that the total cost per mile is changing due to the uncertainty that we have added, bearing in mind the historic data of each one of the cost centers of the trucking industry, right? But that's why we will use Monte Carlo simulation, because this tool will help me, or will help us, to consolidate or combine all of these results in one chart, that these charts are basically shown in this moment, right? But we can automatically obtain all of these charts in the following way. When we have defined, for example, the output variable and then the number of iterations that we want to apply, finally we should click on the start simulation, and basically we will realize that all of these total cost per miles will be part of one single chart that we will realize in few minutes. So this is important because through these charts we will be able to understand what will be the uncertainty of the total cost involved in the trucking service, in the trucking industry, as we could realize in few seconds. Sorry for the inconvenience, so let's continue with this demonstration, right? So if we fix a specific number of iterations, in that case, example 5,000, and then click on the start simulation in order to run the Monte Carlo simulation, we will realize that all of the possible total cost per mile will be combined in just one chart, as we could see in this moment, right? So through these charts, we will be able to understand the uncertainty of the total cost per mile, and to verify if that the fare established by the American Transportation Research Institute is basically correct or not. In that case, for example, they provide us that the average cost per mile is $1.68, right? So in that moment, in the same way that we did the analysis of the probabilistic scenarios, right, of the input variables, we could apply the same logic in these sort of charts, right? So for instance, that probability for exceeding the fare established by this institution, right, is basically the probability of exceeding that is 13.3%, right? Of not exceeding that value is basically 86.3%. That is significant, right? So it's good for those companies that construct their budgets taking into account those cost centers values, right? But if we want to understand what are the cost centers that are affecting significantly the total cost per mile, we can use other tools that are basically the tornado charts. So if we just minimize this chart, we can realize that through at-risk, we can obtain these charts automatically through these functions, risk result graph. In that case, we can specify with this function that I want to obtain the histogram of the total cost per mile after running the simulation, and the following chart that I will introduce you is basically the tornado chart. So if we want to obtain that tornado chart, we can just move on the cell that is a output value, browse results, and then find the option of tornado change in output mean. Well, the tornado chart is explained in this way. So if we fix all of these cost centers, specifically truck trailer leasing, driver wages, truck insurance premium, driver benefits, and so on, right? If we just fix their cost, and the only center costs that will be varying across of the possible values are essentially the fuel costs, we will realize that the total cost per mile will be reduced or will be increased, right? So in that example, if we reduce marginally the fuel cost, we will obtain a total cost per mile of $1.51, right? But if we increase a little bit the fuel cost, basically our total cost per miles will goes up to $1.68, right? In the same vein, we could analyze other sort of cost centers. For example, if we want to analyze the driver wages, the impact of driver wages on total cost per mile, we can just fix all of these cost centers in their current values, and we can vary the cost, the possible cost of driver wages. For instance, if we reduce the driver wages cost, maybe the total cost per mile will go down to $1.54. But if we increase the driver wages cost marginally, our total cost per mile will goes up to $1.65, right? But if we want to analyze the relationship between each one of our cost centers, basically we can construct automatically scatter plots diagrams, right? So we just need to click on in this part, right? And then, for instance, if I want to analyze the driver wages as well, click on that place, and here we are. You will obtain different scatter plots, making the relationship among each one of the cost centers with the output variable, that is total cost per mile, right? So if we analyze the first example, just for demonstration, right? And just let me to change some of the curves that are presenting, because of these curves are basically the scenarios, the possible scenarios fixed automatically by address, and we just have this chart and just add a ellipse with a confidence level of 99%, right? We will realize that relationship among total cost per mile and fuel cost, right? So as you could see, the relationship is positive because of the Pearson and Spearman coefficients are basically positive, right? Close to 1. So if we want to understand this chart, we could apply the following example. For instance, if we want to know what is the probability for exceeding the fuel cost fare of $0.50, as well as considering that the total cost per mile, we won't let that specific fare could increase to $1.68, then the probability of those scenarios are basically 25.3%, right? So it is a little bit probable, right? Or maybe if we want to analyze what's the probability of that the fuel cost could exceed the fare of $0.60, as well as considering that our total cost per mile maybe will be increased to 1.60, right? Sometimes the sliders are a little bit uncontrollable, but we can put 1.60 here, right? So we can realize that that probability is basically 5.1%, right? So in that way, you could perform a bivariate analysis, bearing in mind the relationship among the output variable that in our example is total cost per mile, and one of the key input variables that is the fuel cost, right? So, well, in the same way, you could make an interpretation of each one of these center goals, right? Well, basically, I have finished my presentation. If there are no more questions, I will stop here. Thanks very much for your attention, and see you soon.